This is section 10.1.2. We're going to take a look at period change. So we're going to find the period of a trig function and graph trig functions with that period change. So if you remember with our parent functions, we said for sine and cosine, the important values are going to be those, so those are the same. And then for tangent, it's 0, pi halves, and pi. Now, the period is actually going to change these numbers, and that's going to be important. It's going to change these numbers. So let's define this stretch and shrink. So if we remember that we could stretch vertically, that was the amplitude, and that's what we went over in the previous lesson. So with that 3, we know that I could stretch my function, I could pull it up, pull it down by a factor of 3. But now we can have this horizontal stretching and shrinking, which we call the period change. And it's the value that's going to be in front of theta. That represents our period change. So period is the number of radians or degrees it takes for a function to complete one full cycle. Get this down. This is important. We need to have that. Period change is the number of radians or degrees it takes for a function to complete one full cycle. Now our parent functions, sine and cosine, have that normal period of 2 pi. That's why it starts at 0, ends at 2 pi. 2 pi minus 0, the distance between it is 2 pi. For tangent, it's going to be pi. So to find what your new period is, what you're going to do is you're going to use this equation. 2 pi over b. That's the equation that we want to use, 2 pi over b. So in this instance, if I wanted to find what my period is, my b is 2, so my new period will be 2 pi over 2. That cancels out, and I get pi. Now notice what happened to the function. My old one started at 0 and ended at 2 pi. And then after the period, because of that 2 there, it horizontally shrank down to pi. That's what the period does, is it shrinks or expands your function. So let's look at another one. If I said the graph of theta, f of x equals sine of 1/2 theta, or sine of theta over 2. Now my b is the 1/2. So 2 pi divided by 1/2 divided by 1/2. Remember, you got to flip it, turn it to multiplication, and you get 4 pi. Now if you notice, it starts at 0, ends at 2 pi. This got stretched because of that period. It's like I took the function, I stretched it to that 4 pi. So that is the visualization of our horizontal stretching or shrinking. Now, how does this work out for us? What do I need to do to be able to kind of adjust or fix this? Well, the first thing we need to look at is going to be the amplitude. And so we take a look at the amplitude, and I'm just going to kind of note that to myself. My amplitude is 5. I need to know what my parent graph is. Okay, it says sine. So my sine parent graph, I'm just going to kind of note that to myself. Starts here, goes up, crosses, goes below, crosses. Okay, that's what my parent graph looks like. I can find my period, 2 pi over b, so that's going to be 2 pi over 3. So my period is 2 pi over 3. But now I need to find what these x values are. I don't know what these x values are. Now I knew the old ones for the parent graph, 0, pi halves, pi, 3 pi halves, 2 pi. But I don't know what these new ones are. So I need to find them. And to find them, what I'm going to do is I'm going to take the inside of my function. So this is my inside. And I'm going to put that between 0 and 2 pi, or 0 and the natural period. Remember, it used to start at 0. It used to end at 2 pi. So that's what I'm going to do. Starts at 0, ends at 2 pi. Solve for theta. So divide everything by 3. And so now we get this statement here. Now this becomes my new starting value, 0, and my new ending value, 2 pi thirds. So I just found 2 of those values. Now I have to find the rest. Now the nice thing about it is these values are broken up evenly. So that means that I can find the middle value by adding the ends and dividing by 2. So I can add 0 and 2 pi thirds and divide by 2. Now that's going to give us 2 pi over 6. I can add 0 and 2 pi 6 and divide that by 2. And so that's going to give me, see these 2's cancel out, and so that'll give me pi 6. And then I can add these together, 2 pi thirds, or 2 pi 6 plus 2 pi thirds all over 2. Find the common denominator. So that's going to be 4 to make that a 6, multiply by 2 over 2. And so that's going to give me 6 pi over 6 over 2. And so the 6 and the 2 cancel out, so I get 3 pi over 6. Now, I can change this now. See how they're all divided by 6? It's actually nice that they're all divided by 6 because that means I can actually go through and mark these appropriately. And so I can, it's called scaling. And so I can scale this into 4 pi over 6. And so now I can count it. This is going to be, just kind of draw it on that parent graph that I sketched out real quick. That's 3 pi over 6, and then now that's 4 pi over 6. So now I can label it on my graph. There's my 2 pi thirds, or I can say 4 pi over 6. There's my pi thirds, or the same thing is going to be 2 pi over 6. Pi halves, which is the same thing as 3 pi over 6. It's just the way that I'm labeling it. And then I draw my parent graph. Starts at the center line. The amplitude is 5, so it goes up to the amplitude. It crosses back at the center line. It goes below at the amplitude, and it goes back to the center line. And so then you can sketch your one cycle. So to find your x values, you need to do this box thing. You put it between 0 and 2 pi, and you can find those values. So this one here, I have a reflection. My amplitude is 4. It says cosine, so my cosine parent graph starts at the amplitude, crosses, goes below, crosses, goes back up to the amplitude. Now I just need to know what these x values are. I need to find what those are. So to find what those are, we can help with the period. So this is 1 over 3, so 2 pi divided by 1 over 3. If I did 2 pi divided by 1 over 3, it flips, and so you end up getting 6 pi. So that means my period is going to be 6 pi. So now doing the box, I take my theta over 3, I put that between 0 and 2 pi, multiply everything by 3, so I get 0 is less than or equal to theta, which is less than or equal to 6 pi. Create my box. Starts at 0, ends at 6 pi. So immediately I know that this is 0, I know that this is 6 pi. Add them together, divide by 2, you're going to get 3 pi. Add them together and divide by 2, you're going to get 3 pi halves. Add them together and divide by 2, you get 9 pi halves. So I know that this is 3 pi halves, this is 3 pi, and this is 9 pi halves. So now I can draw my sketch. So this is going to be 0 and 6 pi. So I just label it. And now I can start with my graph. Okay, so I know normally it starts at the amplitude, but because of this reflection, that gets reflected down. So it's going to start down here, then it's going to cross, then it's going to go up, then it's going to go across, then it's going to go back down. And so there's my sketch. Now for tangent, it's basically the same thing, except now we have a new period of pi over b. If you remember our original starting values, it was 0, pi halves, and pi. That means the distance between the two was pi, so that's my period for tangent. It's just what it is. So that means instead of 2 pi over b, it's just pi over b. To show a visualization of that, if this was my tangent function with my old period pi, because of that 2, pi over b, pi over 2, that's my new period. If you notice, that value got kind of shrank. It's got pushed on, and so got moved over. And it looks just skinnier because of it. So sketching the following for one full rotation. So for tangent, pi over b for my period. And so if I were to go through and sketch it, when we do our box thing, instead, normally it was 0 and pi. You still take it between 0, but instead of 2 pi, it's going to be just pi. Divide everything by 3. So you get 0 is less than or equal to theta, which is less than or equal to pi thirds. And so my first value is 0, the second value is pi thirds. Remember, dad dot asymptote dot. So to find that middle value, add them together, divide by 2 because it's in the middle. So you get pi 6. And so I know that this right here is going to be 0. I know it's going to be pi 6. I know that this is going to be pi thirds. Now I can go in the negative direction, right? So it looks like it's going up by pi 6 every time. So this is going to be negative pi 6. And then if I keep going that way, that'll be negative pi thirds. So then this is negative pi 6, and this is negative pi thirds. And so we have our dot asymptote dot. You just continue the pattern forever. And then because it's negative, normally tangent goes that way. Because it's negative, that's going to flip. So now it goes that way. And so we can have our tangent graphs. So what did we learn today? We talked about the period change of a function. How do I find the period of sine and cosine? It's 2 pi over b. How do I find the period of tangent? That's just pi over b. And remember, to find your new x values, you put it between, you could say your b theta or whatever, you put that between 0 and your old period. And the old period for sine and cosine is 2 pi. The old period for tangent is pi. This does conclude our lesson. If you have any other questions, please leave them in